So we're going to finish up here with naming acids. I think we covered some of this the other day, but we're going to go over it a little bit again. So if the acid contains oxygen, acids always start with H. That's how you recognize them. If it has oxygen in it, then we're going to add the suffix "ic" to the root name if the anion ends in 8. So if we look at this one, I'm just going to adjust my, there we go. HNO3. If we cover up the H, what do we have left? NO3 is nitrate, right? We're changing nitrate to nitric. We're changing the ending. So this is from nitrate. The 8 becomes ic. And so I have a silly sentence for you. Rick ate him before he could bite us. Is that silly? Okay, so there's us and there's ite. Those go together. Oh, great. Oh. And it has vanished into the ether. One of these days I'll have time to play around with that. Okay, I'm going to do this. Maybe we can get this to stay. Yeah. Okay. Right? Yes? Can we do this? Sure we can. Ic and 8. Okay, that's spelled wrong, so it's a little bit of a stretch there. Ic and 8 go together. Those are a pair. If the ion ends in 8, you change its name to ic. Nitrate becomes nitric acid. Sulfate becomes sulfuric acid. Phosphate becomes phosphoric acid. Okay? If it ends in ite, you change the ending to us. So ic and 8, ite and us. Oh, good. So on this guy, we cover up the H, we see nitrate ion, that's nitric acid. Here, H2SO4, cover up the H. SO4, what's the name of the ion? Look it up in the table, it's sulfate. We change the 8 ending to ic. Now, sulfur and phosphorus are a little bit weird because that UR from the element's name comes back in there. Sulfate it's not sulfic acid, it's sulfuric acid. I'm not sure exactly why. I'm not going to trick you on an exam and put sulfic acid and sulfuric acid and see if you remember, okay? So I'm not going to trick you on that, but just be aware that sulfur and phosphorus do that. Maybe it's because sulfic acid sounds dumb. I don't know. HC2H3O2. Oh my goodness, all those letters and numbers. It starts with an H. It's an acid, okay? So cover up the H. It's got oxygen in it. See what's left. C2H3O2. That must be a polyatomic ion. Look it up in the table. That's acetate. Acetate, we change the 8 to ic, and it becomes acetic acid. That's the acid that's in vinegar. And it has that distinctive smell. So if the anion has the ending "ite," we change it to "us." HNO2. Cover up the H. NO2 is nitrite. Nitrite becomes nitrous acid. So there's nitrous acid and nitric acid, and they are different. One's HNO2, one's HNO3. H2SO3.
What make them different?
The number of oxygens. This is NO2, it's nitrite. This is SO3, it's sulfite. Well, the reason it has the extra H is because it's 2 minus. So SO3, good grief. So yeah, the next one came up. We'll ignore it for right now. SO3, 2 minus. It has a 2 minus charge, and so then it needs 2 H pluses. Okay. So SO3 sulfite becomes sulfurous acid. HClO2. It starts with H. It's got oxygen in it. It's an oxy acid. It's an acid with oxygen. You cover up the H and you see what's left. ClO2 is chlorite. So ite becomes us, chlorous acid. So I'm going to let you have a table of these ions, because I don't want that to mess you up. I want you to focus on learning how to change the names and to put the ions together to make compounds. I don't want you to get tripped up because you just don't remember the formula for acetate. Okay? When you go on to your next class and you're going to have some knowledge of how to put these things together, then you can spend your time memorizing those guys. So these are some common acids: nitric acid and nitrous acid. So there we see them right next to each other. The difference in their formulas is 1 oxygen. This is nitric, this is nitrous. This comes from nitrate ion, and this comes from nitrite ion. Sulfuric and sulfurous. This is from sulfate, this is from sulfite. The difference is 1 oxygen. Phosphoric acid comes from phosphate, and acetic acid comes from acetate. Any questions? So there's the flow chart that your book gives you, which you may or may not find useful.
When do you use the hydro?
The hydro is if there's no oxygen. So if you have HCl, that's when you get hydrochloric acid. Because Cl isn't chlorate or chlorite, and so you can't use the oxyacid rules of changing ite or ate, because there is no ite or ate.
Well, so use the full name hydrogen when it has an oxygen. You're using the full hydrogen phosphate. You're not changing it to hydro. Only change it to hydro when there's no oxygen.
You use the hydro prefix when there's no oxygen. If there's oxygen, hydrogen doesn't get mentioned at all. Nitric acid has no hydro or hydrogen in it. Okay. So let's look at these. Which of the following compounds is named incorrectly? So, as a multiple choice exam question, this is a real tedious question, and I don't ask ones like this. But let's look at these and see if they're right or not. KNO3. Is the correct name potassium nitrate? Well, let's think about this. What kind of a compound is this? We have to look at the first element. Is K a metal? Yes, it's way on the left side. This is a metal, so it's what kind of compound? Ionic. So K is potassium, correct? Yes. Does potassium need a Roman numeral? No, it's in group 1. It does not need a Roman numeral. Okay, so this is okay. So K, we'll cover that up, and what's left? NO3, nitrate. Okay, so this name is correct, potassium nitrate. Let's look at the next one, TiO2. Ti is a metal or a nonmetal? It's a metal. It's on the left side there. Is its name titanium? Yeah. Does titanium need a Roman numeral? Yes, it does, because it's not in group 1, 2, or 3. So it needs a Roman numeral. Okay. What Roman numeral should it have? Well, why should it have 2? How can we tell what it's supposed to have? We have to look at the charge on the anion. What charge does oxide have? 2 minus. And there's 2 of them, right? So that's a total of -4. And there's only 1 titanium ion. If it's +2, is this going to add up to be neutral in charge? No. So that should have the Roman numeral 4. So that one is not correct. You see how I did that? You have to look at the anion to figure out the charge on the guys that need Roman numerals. How about the next one, SnOH4? Look at the first element. Is it a metal? Tin. It's to the left of the stair-step line. I had a couple questions about what do we do with the semi-metals? If the semi-metal is on the metal side of the line, treat it like a metal. If it's on the non-metal side, treat it like a non-metal for naming. We don't have a separate set of rules for semi-metals, thank goodness. So this is a metal. Does it need a Roman numeral? It does. It's in group 4A, but we don't care about that. We care about group 1, 2, or 3. So it needs a Roman numeral. So we've got tin and a Roman numeral, so okay, we're doing okay so far. We'll cover up tin, and what's left is OH. Is that hydroxide? Yes, it is. So OH is hydroxide. Now we need to check that charge. So hydroxide has a -1 charge. And there's 4 of those, right? Parentheses with the 4. So if we have 4 of those, that gives us a total of a -4 charge, right? And in SnOH4, there's 1 tin. So it must have a +4 charge. Is that the Roman numeral for 4? It is, because 4 is 1 before 5. So that one's correct. Let's look at letter D. PbR5. Okay, look at the first element, phosphorus. Metal or non-metal? Non-metal. So non-metal and non-metal, this is going to be where we use prefixes. So we've got 1 phosphorus, so we've got phosphorus there. And then there's 5 bromines. Is penta the right prefix? Yeah. Penta, bromide, and they remember to change the ending to "ide." It's not pentabromine, it's pentabromide. So that name is also correct. How about this one? H2SO3. We look at the first element. Oh, that's hydrogen. If it starts with hydrogen, it's an acid. Then we look, does this have oxygen in it? Yes. So this is one of those oxyacids. What we're going to do is we're going to cover up the hydrogens and figure out the name of that polyatomic ion. SO3 is sulfite. Rick ate him before he could bite us. Ite and us go together. So sulfite becomes sulfurous acid. And that one's also correct. Okay? These are the sorts of things we need to know how to do. Okay, there it goes. So that's the one that's named incorrectly. Type 3 binary compounds. What we're going to do here is we're going to stop the recording.